So welcome to the second meeting. Just for full disclosure, I took a couple of examples and figures from the math work. Just I don't want to plagiarize anything. So last time we just last week we just familiarized a little bit with MATLAB in general with the documentation. And today we'll focus on vectors and matrices and matrices manipulations. Now, I divided matrices manipulation into two parts because it's like there's like just so much stuff. But if we can make it, it would be nice to like do everything today. But like we're flexible, so no rush. So if we can do both parts, fine. Otherwise, we'll do the second part of matrices manipulations next time. So have you watched the movie The Matrix? There is this scene where like Morpheus, this person in the figure here, offers to the protagonist a choice between two pills, and then if the protagonist chooses the red pill, then you can follow him like into the Matrix. So that's what the slides was about, but that's okay. So let's just start then. So before introducing the concept of like matrices in general, it's very important to introduce the concept of arrays. So there is a secret. Virtually in MATLAB, all variables such as that contain numbers are arrays. This means that so each numeric variables can contain multiple variables. And then also you can use arrays to store every data in one variables. And so matrices are arrays, vectors are arrays, and scalar, which is like this one by one array are arrays too. That's a very important concept to keep in mind. So for example, last class we saw like we named some variables with just like one single variable, and this also an array, and it's called scalar, as I said before. And a scalar is just an array that contains one column and one row. And also you can create arrays with multiple elements if you use like the square brackets. And it doesn't matter if you put the comma or if you just like space them out, and MATLAB will read it exactly the same way. So if you put, if you space the elements, or if you put like the comma in the square brackets, then MATLAB will read it as a row vector. And if you separate the values in an array with a semicolon, then MATLAB will create column vectors, like here, for example. And so when you want to create a matrix, you just have to put like rows and vectors together. So for example, here we have like 3 elements spaced out. So it's like the elements of a first row, and then like a comma, which means, okay, here it starts a column. Yeah, so basically just combine space and semicolons to create a matrix, which is just an array with multiple rows and columns. So if you want to do like some operations with vectors and matrices, if you use only scalars, then it's not tricky at all, because you can just add a scalar value to all the elements of an array. And it's exactly the same process. It's very similar for like divisions and multiplication, like in this case. And so here, for example, you have like x equal 2, 3, 4. And then like if you just like add 10 to like this array, then you will have every element plus 10. If you want to do matrices multiplication, then you have to keep in mind that if you just use the normal operate multiplicator here, it will probably produce an error message, like I think 90% of the time. So you have to put like a dot before this multiplication operator. And that's, oh, sorry, it keeps like popping up. And that basically with what will allow you to multiply two matrices of the same size. If you want to like multiply matrices of different sizes, possible, but it's a little bit tricky, and you can find about it like in the documentation. But the best way like is to try to how do I say it? Try to like make the size of a matrix is like with reshaping a matrix to make it of the same size of the matrix you want to like work with. So for example, you have two matrices, then you can reshape the second matrix to have a size of the first matrix, and then you can work with two matrices of the same size. That's the best way to do it. Otherwise, it gets complicated. And so when we work with matrices, there are some useful functions that you should remember. So I'm just going to mention them, but then you can play with them when you want. So the zeros function creates a matrix full of zeros. It's very useful when you want to, for example, just like create an empty matrix of a certain size, a certain like shape, and then fill it with the values that you want. Because otherwise you think like, oh, why I need like a matrix with all zeros? But that's basically why you need them. And then the same thing is ones. So basically creates a matrix full of ones. Then you have the size function that just tells you the size of a matrix. So for example, how many rows, how many columns. And don't confuse the size function with the length function, which tells you the length of a vector. Then last week, maybe you remember that we used the function rand, where basically creates random matrices with numbers from 0 to 1. If you want to create random matrices with numbers with integers, so numbers from 1 to infinite, but they're like, for example, like 16, 50, 18 without the decimal parts, then you have to use randy, which it works basically this exactly a similar way, just that it gives you integers instead of floats. Float are the numbers with the decimal parts. And so rand, it's a function that takes few arguments. The first one, it's the maximum value contained in the matrix. So max value here. Then the second one is the number of rows, and the third one indicates the number of columns. So for example, here, x equal randy 15, 4, 5 produces an output of a matrix that is 4 by 5 with random numbers from 1 to 15. Okay, now you can open the script that you downloaded, and please stop when it says like end of the first part. So it's like up to the vector section. So for this part, we'll like just do it like everyone by itself, and then we'll do the break rooms a little bit later when the exercise gets more complicated. Okay, so the goal of this task was simply to frustrate you. So I hope we succeeded in that. No, that's I just wanted to tell you a general rule in MATLAB. I think for like it's not just for MATLAB, it's just like when you code in general. So every time you feel that something is repetitive while you're coding, or like that you're getting bored because you're just doing the same thing over and over, that means that what you're doing can probably be automated. And so you can make the code more efficient. That's like a general rule. Now, in this case, a quicker method to create evenly spaced vectors is to use the column operator. and specify so only the start and the end points. When you have the column operator, the square parentheses are not needed. This column operator has a default of 1, but you can also like specify your own like spacing. For example, like here we have, I decide my own spacing variable, and then so you start with the first number, there is the starting point, then you decide the increment, in this case 2, and then the end point that is 20. You already know the transpose operator from last week that we used it in the exercises, which basically convert a row vector into a column vector. But maybe you don't know that you can also transpose the variable while you're creating it, like here. And then another important function when you play with vectors is Lin Space. So if you know the number of elements you want in a vector, but you don't know like the space in between each element, and so you can use this function. So if you can go back to the MATLAB file and play with it, yeah. Okay, now finally, we'll see how to access a matrix or a vector. So first of all, we have to define what we mean by indexing. And indexing refers to how to access, extract, or modify elements from an array. So the index is only the position of a value inside an array. And so you will access most of the time like a vector, a matrix, a cell, or whatever MATLAB like type of array, indicating this like index. So if you want, for example, the third element of this vector x, you just have to type like x, so the name of the vector, or the array in general, and then in the brackets the position. So in this case 3, and then the output that you will have is 6. If you know the position of an element, you can also modify its value directly. So in this case, for example, here we had 6, but now we don't want 6 anymore, and so we can change it with like the value of 1. So name of the vector, in this case, position, and you access these elements, and then you substitute it with 1. You can also extract a range of values by expressing the first and the last position of your range with the column operator. And so in general, when you work with vectors, you only need one index or a range. But when you work with a matrix, of course, you will need like two elements to specify 2 elements, because we work with rows and columns. And so if you want to extract an element from a matrix, you have to specify, first of all, the position of the row, and as a second argument, the position of the column. So in this case, we have the name of the array, which is a matrix in this case. Here, first row, 1, and 1, 2, 3, third column, and we have the value of 6. If you want like if you want to access all the whole row, then you can use, or also the whole column. You can use the column operator. So the column operator in this case stands for all, the whole set of values. So here in the first example, you're extracting the whole first row. So you specify the first row and then all columns. So every column. And here you specify all rows of the third column. To sum up, with vectors, you only need one index or the range. And with matrices, you need 2 indexes, the row and the column. Now let's try to play with it. And I'll divide the break rooms Also, we still have some time, so we might actually finish the whole matrix manipulation. So I'm gonna, in the meantime, then create the break room. So I'm gonna send you via email some exercises that were meant for class 3, and we can actually try to do them today. Okay, so let's go back to just like 1 more minute, and then we're done. Don't worry. So we basically finished the second part. So next time is gonna be only cool stuff. Yeah, from next class is really gonna be cool stuff. And then, yeah, that was like the bonus part. So that was the main solution and like the main issue. So if you want to select an element, I mean, like multiple like elements that are not consecutive, so you cannot use the column to determine a range, then you basically have to use the square brackets inside the normal parentheses. So if you have a vector here that it's like 1, 2, 4, 8, 7, 10, and you want to access, and this is the index 1, 2, 3, 4, 5, 6, right? This is the indexes. So you want to access the number 4 and 6, then it's gonna be X, then you open the normal parentheses, then you open the square brackets, and then position 4 and position 6. In the square parentheses, in this context, you don't need the comma, you can, so it's like optional. And then you close this, and then the output is gonna be 8 and 10. So that's the main solution here.
I have a question.
Mm-hmm.
So what if like you have a matrix, for example, like 2 by 3? How do you know like what is like the first or the second vector?
So a matrix goes like the first index of the matrix is the row, and the second index of the matrix is the column.
Okay.
So you have to go in this, keeping this in mind. Now the best is gonna get tricky sometimes. So the best suggestion I can give you, the best advice is that just print stuff. Like try things out, print it, and see like what the output is, so you can infer. And then you go from there, because sometimes you just get confused, and that happens to me all the time. So see you next class. Bye.
Thank you.